Hi, good afternoon, everyone. I look at your face, I feel a bit, I think you guys are tired. But today, I will not give you any exercise. I hope I share to you about a technical side of how me and my team as Foxconn that we built the foundation model. And we turn this, the general purpose model to a domain specific that's used in our application. So I hope by sharing our story and the technique behind our team that can give you some idea and also some technical background for you to go back and then you continue to build for your domain or your application that you are trying to build now. Before I will share about detailed technical, I will try to introduce you guys a bit about the reason and what we're doing as Foxconn. So our team at Foxconn, we built a foundation model that's called FoxBrain. So this FoxBrain foundation model that built to support Foxconn 3 strategic platform service, including the smart manufacturing to smart EV and smart city. Inside smart city, we also build healthcare system inside it. And the story is about FoxBrain, but it's not a single model. It's a series of the foundation model that built to serve a different application, a different use case. They require a different type of model. Architecture are different, and the way we train it and the way we use it are different. From the language model, as you are familiar, right? The language model like AI chatbot these days from ChatGPT, Gemini, or Claude. So these language model as Foxconn, we also building, but we focus more on the reasoning capability, enterprise agent workload. To the multi-model, which is a vision language model that we also try to build and specialize this model for industry purpose, not the general purpose, but it still can use it for a general purpose. To the word or action vision language action model that's used to deploy and embody into the physical robotics in the smart manufacturing or in the driving. So this model need to act in the environment. And to the version that we built to make the human collaborate with the robot or physical AI in the environment, how the human and machine can work together in this factory floor or the autonomous driving on the street. And I try to show with you the 5-layer cake at Foxconn. The bottom layer is a chip, right? The accelerator can be GPU, graphic processing. So for us, we build with the NVIDIA GPU base with the latest from Grace Blackwell or Vera Rubin. And another type of accelerator you might have like TPU or the ASIC that designed for train or inference these language or foundation AI model. And on top of that is AI development framework, right? So the community have wide range of AI development framework you might choose. Is as long as it's suitable for your application and for your hardware that you can access at the current state. And on top of that, you will produce a model, right? The model is the center of everything. So when you have the in AI factory, and then on top we have the AI development framework, you will have the produce the AI foundation model, and you specialize this model for specific functionality. And then you can use a special functionality model to integrate or plug in into your application. For our showcase, we use for autonomous driving, we use for smart manufacturing, we use for smart city. And to build this model, the pipeline is complicated, but I simplify it to 3 pillars for you. You can easy to understand and keep in mind what is important for you to building the foundation model. So first, how you build the high quality data engine at scale. with cost efficiency. The second is how you train this model. If you have a large amount of GPU, how you train it efficiently. When the model is big, the data is big, you have to train it efficient. Otherwise, you will losing the capability of the compute cost that you have. And last, how you evaluate this model, especially if your field or your domain, you don't have any kind of benchmark, you don't know how to evaluate this. So I will try to share with you how to do it. And before I jump into the building the data engine, so I have a question. Any of you here already building the data corpus to train the model? You can raise your hand. I can understand. Oh, okay, you haven't built. So any of you have a team more than 10 people? Okay, so basically you are individual, so it's good. That's the purpose I try to show here. So for us at Foxconn, we don't have a data label team, just me and cluster, and GPU cluster. You just need a cluster. You can build. Just need GPU and open source model. You can build this data engine, and also training as well, and also benchmark as well. If you are individual, I think this also suited for you to try out. So the concept I try to deliver for you is how you use AI, manufacture AI. So it's a simple term. And the idea, so we have a different type of application, different type of data engine, from text to vision language, to video, to physical AI, to autonomous driving, many kind of domain. You have a different modality of input data. How you build this data engine, right? So it's important. And at the center, I try to give you a hint that you're using these foundation model base that you can access. So mostly for us, we use open source, but if you can access proprietary model, it's great, yeah. And before we jump into detail, what exactly a data engine itself? So a data engine is how you process the raw data to become a training data. You can just think it's different, right? You have a raw data. It's not a format of training. First you have to process this, download it, process into a certain format. How you validate this content or the training data is good enough to train the model. And even how you improve the data. If you see it's not really good, how you improve it, right? This is a functionality of data engine. And the data engine is not just one-time iteration. It's a series or the iterative improvement. You have a better AI model, you can produce a better curation, better processing, better generation, better improvement. Or you have better evaluation and better curation. It's like improve over time. When you have better data, you can train a better model. That is a simple fact that if you look at this stage, you train the AI model, you have to have the high quality data. Otherwise, you can't train the smart model or the good model after you take the open source model. And the one philosophy like I mentioned earlier, how you just individual, you can build this data engine just using AI model itself. So first, let's jump into the language data pipeline. So in this, I want you to see on the left, we have a raw training corpus. Right now, you can easy to access trillion of tokens from Hugging Face. Any of you here knowing Hugging Face? Okay. It's like a repository of model that you can download, data available, and a lot of people sharing a lot of cool thing that you can access publicly available for everyone to download and get the data or a model. So you have a data source on the left side, and you will do a lot of rule-based or heuristic processing like, okay, character filtering, repetition, or n-gram, like how many words that repeated in the content. And the one I want you to pay attention is the green neuron icon here, which I mean this is a foundation model base, which is you can use all kind of the LLM model that you can access right now. You have from the model from Google, you have Gemma, you have model from NVIDIA, you have Nemotron, you have model from OpenAI, GPTOSS, you have model from DeepSeek, right? You have model from Alibaba, so many model you can choose. So this model, you can see the functionality I divide different. So you use your model for classification, quality checking. So like to reading each of the training sample right now, if you use human, it's impossible. You can just imagine a trillion token is like a library of books. How can you read all of the training sample to classify by yourself? It's impossible. So this model can just help you to read all of the sample, give the score, like whether this score of 1 to 10 or any kind of scale that you can think of, and then you can use that to like verify, okay, if the higher score, the better of training sample it is, right? And this, if you have the model produce score of training sample, it's not good. You can continue to use this model. You can specialize certain kind of template or prompting this model to help you to improve the content of original sample. So basically, you just say, okay, I have this context. I feel it's so just not good. It's too messy. I want to write it into structure. I want to write it more well-connected from beginning to the end or from middle, right? So these parts you can easy now to asking a certain model to help you to do this. It will produce a satisfied sample for you. You can try out after today when you try to improve some sample. And so from this data engine, when you using model to help you classify, to enhance, you can get the kind of domain data that you want, right? You can easily to classify in certain domain that you want. From us here, we try to show example. You can group all of these training sample into a domain that you want. For us, we have like roughly around 38 category. And then we divide it from strategic core, which is the most important for us, right? To the bottom layer, high value document like math, medical, or coding, or a lot of high value is depend on you how you treat it. And then to long tail problem, to the high volume. High volume is kind of like all kind of other things that you want. And the important thing that when you train the model, you want to preserve the model general capability. You have to find a way to mix all of these categories together. Otherwise, you are facing a problem when you train the model. The problem is the term called catastrophic forgetting, which is the model is forget what is learned from like the past when you train on a certain domain. So the idea of how you combine these data mixes into a certain proportion of different kind of category to preserve the model knowledge. And also when you do processing the data, I want to show you one case sample. This is one of the simple idea is go through a data engine. You have raw data, you have to do quality filtering, you have to do rephrase or enhance the quality. The point I try to show here is you have a different category and do you know different kind of model is good, right? I have a Gemini, it's good for coding. I have a Gwen, it's good for math. I have the GPT-LSS, good for writing, right? So I can use these kind of different model to pick different category of data to help me to process, to enhance my data. At the end, I will have kind of all kind of good thing from different team. Example, from a team Meta, they have Llama. I have the good thing from Llama model. I can easy to look at its benchmark or technical report. It will tell you detail how good of this model perform on certain domain. You can check detail and then you say, oh, this model good for math. Then I will pick math data for this model to process, right? And that just simple idea, just model do it. You can see at the end, you don't need to do anything. Just host the model, run raw data through it, and then it's produce the output, and then you save it, and then you get the data. This is how you can process for pre-training or post-training, just a matter of format, how you design and how you format the data. And then you continue to add the complexity for data, right? I just show you just language only, but now you adding images, and then the complexity is growing. And then you might have adding more component to it. So you have image, now you have to make sure the image and text are aligned together, or just completely two different things, right? And you also have to continue to do the duplicate or to quality filter whether this image are good or text are good enough. And then after that, you need to continue to generate different kind of text annotation. So I give you one example. You can easy to get the image and text on Instagram, but how many of you here post the image and your captioning is all completely two different things? I did a lot of times. So maybe I can post something and then write my status. It's not really describe the image, but just one of my comment on it. So this kind of data you have to make sure it's matched right. Otherwise, you just discard the text and then you have to regenerate the caption, right? Or you have to regenerate the annotation again. So that's just the important thing, that you need to generate more annotation, either captioning or either some tasks like question answering, VQA, grounding, and all that stuff. And you also domain classification, and then you can also enhance the existing description, right? Existing annotation. It's not good enough. You can continue using a VOM to help you to write it better, or write a different question and let the model to answer, right? And similar to language, when you build this corpus, you can easily to split into a different category, right? And then you can treat it. It depends on your application or the domain that you build. You will treat strategic core different. If you are building for medical, absolutely the medical should be the important category, right? Should be in strategic core and other. And I think I have one visualize to get the idea. So here is kind of like high value document with image and text. And we have high volume like capture, portray, and many natural things to part of strategic core for us like factory and how some reasoning to understand some logic, planning, etc. You would treat it as some certain part of your corpus that you purposely build to train the model or specialize this model for your application, right? And you continue to add the complexity. Now from image and text, now you're adding video, right? Video is continue increasing the time dimension, and the content is getting more. 1 second of video is about average 32 frames per second. So it's just 1 second of video, you have 32 image, right? 30 or 32, or even higher. It depends on the video type that you get. And now from video, you have to treat it differently. So now you have very long video, how you cut to a certain section that you purposely want. It's important how you detect it, how you build a mechanism. And you just pick the model, help you watch the video. So now this open source model can handle up to an hour of video long, right? And then you can just, using this video VOM model, help you watch the video. You don't need to watch by yourself. But you purposely specialize into different tasks to let them to help you to handle it. And then you can do dedup in any similar thing. But in here, for video, you continue to do from very coarse to fine annotation. A coarse like, okay, you can do some clip annotation, captioning, to keyframe detection, to certain segment of video now you want to pay attention to it. So that will be like, you have to build multi-level of the visual analyzing or annotation, right? From localization to common or to object detection, many other things in the visual you have to detect and build many different modules to help you to annotate your data pipeline. And from example here, we have many corpus of a training video, but you can sort like the way I show you early, strategic core to value to consumer. And for us, I want to show you one of the important 4 domains that we pay attention from. Okay, from human activity to the factory operation to robotics to driving. So these kind of all domains that we want and we focus. So we have to append a lot of these video and do processing and build our training corpus at scale, right? We have to build by ourselves, otherwise sometimes you can't find some data that suits for your application right away. Then you have to customize and build it by yourself. And that's just 3 pipeline, and then you continue to go through a new direction. Like right now, you can see like physical AI, right, from robotics, and now you have to have a different way to design. Maybe, and here I want to show you from like, you have a real, it's like the data you capture from a certain type of physical AI, like a robot can be the robot on the wheel, or humanoid robot, or even the vehicle you drive on the street can be captured by a lot of camera, right? And then you can also using simulation. How many of you here heard about Isaac Sim or some of simulation tool? Okay, yeah. So basically now you can even generate some kind of task or some domain using a simulation for robotics. Yeah, it's a lot of tool available, but I just mentioned some popular like Isaac from NVIDIA. And last piece is green color here. You can see in the middle, which is the generated. Have you tried generate video from Google VO3 or some AI? Yeah. So now you can also using this model to help you to generate the new video, right? You want something? Oh, I want some task that not exist. I can easily using video generated model helping me to generate video, right? So we can use video generation. You can use either a video existing. You can use transfer. The transfer model help you to transfer different style, color, skin, color, and temperature, anything you can change using these kind of generative model right now. And I want to give you an example here. So I have a stage one is image and text input. So example, I have a robot at home. So now I want to think about, okay, I want the robot to pick the banana instead of apple, right? Or I want the robot to pick apple instead of banana. If I want to do it, I have to control a robot. Maybe I have to set up a robot here and do control by myself to pick a banana or apple. I can't do it for maybe more than 24 hours, right, a day, right? But how can you get a scale at the million of video to train the robotic AI model? It's impossible, right? So you have to use generative. So in this case, I can either using text prompt to let the robot to pick the apple or to pick the orange or to pick the banana or to pick the water bottle, easily just using prompt and let the model to generate the content, right? And then from that, I think I haven't complete. From that, I can using the pseudo generate an action, right? This robot is a real physical AI. It needs to have the action to operate its motor, right? Each robot has a lot of motor. It has a value to operate. So I can generate the action. So I think, yeah, this one video. So it can generate action for a robot to operate, right? And then from that, I can have these video and its action, and then I can train back to my embodiment robot, right? This is one of kind of example for physical AI. Yeah, so after this, how many of you now have some kind of confidence to build the data engine by yourself? Still? Okay. Okay, maybe I'm not provide detail enough, but I'm not have any example here for you to build. But at the section from earlier from NVIDIA, I think you can use that API, calling that model, and prompt it differently and give it input, and then let's see what it generates. That's one you can just easy to get practice. Okay, so now it's training model. It's one of expensive, also as expensive as a data engine. So to train the model, we have to think about how we design the model architecture, right? Today, there's a lot of frontier AI model architecture or release open source about its architecture. You can easily to look at a DeepSeek paper or NVIDIA Nemotron paper. You will see how they design the architecture. They have to design it like the mixture of expert, or they have to design the way to avoiding the self-attention with the problem of quadratic scaling when you have a longer context input, right? The quadratic computation that when you have longer, you need to have a bigger memory of the chip to host or to do a self-attention mechanism to do multiplication. So this is, people do a lot of different ways to do attention, from linear, from a lot of different kind of attention to help to increasing the context. A longer model is a more memory you require to do training and also inference. So people do like Mamba, if you heard about Mamba, which is one of the solution to avoid the quadratic memory bottleneck with the linear state, with the state Mamba, state space modeling. And even the model, the team go further with mixture of expert and latent MOE and many other kind of technique to help you to train and build a better model that efficient in terms of memory, in terms of throughput during training, and how it's efficient in terms of parameter, right? So how many of you here have a cluster of 8 GPU? Or 1 GPU? Okay. So I want to share from our team here is one of the latest or the cutting edge hardware is called NVL72, which is the giant GPU. Is one machine have 72 GPU chip inside, but it's all communicate together with a very high bandwidth communication, NVLink and NVSwitch. And the idea of when you have a model, the model is big. You cannot fit into one GPU. You have to think about different parallelism, right? To shard your model across different GPU, different machine, to host the model to train it. So a lot of different parallelism from data parallelism. Basically, you have data, you split into 5 different batch, right? And then you feed these 5 batch parallelly, right? Instead of sequential. You feed it as simultaneously 5 batch at the same time. It's a data parallelism. A tensor parallelism, you can think, I have a model layer, and then that layer I have to split into half. Half of this layer on GPU1, and another half I put in GPU2, right? And path parallelism is like I have several layer of model I put in GPU1, and another layer I put in GPU2, etc., and so on and so forth. As long as I can fit my large model on this GPU, right, to train it. And so expert parallel, basically you have a different expert in different GPU. It's a simple idea. And for you can write out a lot of options for choosing the training framework, right? And one example here I show is NVIDIA NeMo Megatron framework that you can use to, let me turn on the laser point here. You can use for different stage of training. So to train the foundation model, basically it comes to 2 stages, the pre-training and post-training. The pre-training you might do only one time, but the post-training here, you might do a lot of times. Believe me, you might do a lot of time. For me, I have to do more than 10 times for one version to get the best model out. Before I deliver you the model that work well, I have to train 10 different times, different algorithm, different techniques. I will show you detail about some of technique or some of recipe for you to practice. And earlier I showed you the parallelism. The purpose I show you the parallelism is, if you have a cluster, you set up the parallelism. For example, here I set up like, I have a tensor parallel is denote TP, and expert parallel denote for EP. So with different tensor parallel and expert parallel, I have a different throughput from exactly the same cluster. What does that mean? It means if I set it wrong, I will train the model much longer. But I set it right, I will train much faster. It means I utilize GPU better. So you have to do experiment about configuration of model parallelism to make sure you find the best setting for your case, for your model size, for your architecture, for your hardware that you can access, either H100, A100, or other type GPU. You might to consider this to have the best throughput at your training. And like I just showed you, pre-training, In here is a workload for a multi-model, is a vision language model. But I will not show you a lot about pre-training. Like I mentioned, pre-training is very simple. It's either next prediction, next word prediction, or next state prediction for physical AI, right? Right now you can easy to read about word model is they talk about next state prediction, or training language model is the next word prediction, right? It's simple, just the same for everyone. But the both training here is different. Every team, either Anthropic, Google, or any team, they will have a different recipe. They might not show you, but someone that doing publicly like DeepSeek, they will show in tech report that how they train the model in both training. And I give you example here. Here is a pre-trained model I have from pre-training, right? I have a model output from a next word prediction or next day prediction is pre-trained model output. And then now I have to take this model to train, continue to train. The difference is pre-training, you can think is like you make the model knowing thing, remember a lot of things on your data. It's remember entire internet data, right? Or is obtain a lot of knowledge at this stage. But to make the model to do a certain task or to reasoning, to think through before its answer, or to follow a certain instruction, you have different kind of instruction from translation instruction, from QA instruction, from summary instruction, different kind of instruction you have to do at this stage. And the top here is the recipe that the OpenAI trained the first version of ChatGPT. It's released 2020. But now this pipeline seems to be a lot of pipeline recipe that far more efficient, far more better than this earlier version. So the one highlight yellow here is one of current Soltar recipe you can use to train post-training your model. So in here is a lot of stage, right? I will walk you through it, don't worry. Okay, the first stage is like supervised fine-tuning. What it means supervised fine-tuning is you have a kind of the task that you want, right? You have to build a label. Like you have, it's very simple, Q&A. You have question and answer. The answer is right by yourself, or either you're using some model that help you to answer. And then you just basically at this stage, you're teaching the model how to mimic your answer, right? Forcing the model, okay, this is a question, and this is the way the model have to answer, right? Follow your label data and to answer to solve the task, right? It's a simple idea, training model to mimic or to answer a certain task. A second stage is teaching model to reasoning. Before its answer, think. And the common term in technical term is like people would say, produce a chain of thought before the model produce a final answer. So in this way, one of the technique like GRPO is very early and also popular. It's like you let the model to come up with different paths to solve the problem, right? It can come up with 10 different paths and then produce the answer. And then the answer we can easily to verify, right? If I have a math question, I can easily to extract the final answer. If the final answer not matching with my ground truth, then that's answer is wrong, right? I can easily to verify through my training corpus and let the model to explore a lot of things to come up with a final answer. So in this way, you can think teaching the model reasoning is like explore different direction to answer the question. And the third stage is you continue to refine it. When it's explore so many paths, but maybe one or two paths is the most efficient one, right? In this stage, it's like you sampling a different answer. For example, I have one question, I sampling 10 different answers, but I can choosing the best answer from that 10 different answers. Even these 10 answers are correct, but I can choose the best one. And in that case, I can just make the model to choosing or learning the best one, right? That one is kind of, you further refine the model from its answer. I'm not just create something new, but just from itself, right, to sampling it. And the last stage is more for the task, I think here, if you build medical, is what you will encounter this one. It's kind of like you teaching the model to reasoning, but a lot of tasks, we don't have a ground truth, or we don't have a verified answer. I give you an example. Can you write a story for the kid, like 5 years old kids, about the moon? I can write a paragraph about 10 words. Maybe you can write a paragraph about 20 words, or you can write a paragraph about 1,000 words. All is right. Maybe we have a different preference. We have different kind of knowledge base, but we can write different answer, right? In this way, it's like you can have to build your own custom reward or custom function. In this way, you have to define a lot of different criteria that you think for you is important, right? On the left side, I can build a different environment portfolio. In each portfolio, I define 10 different criteria, or maybe more than 10. I can define 100. It's up to what I decide, right? In this case, I can define a lot of criteria to judging whether this answer is satisfy my criteria. If it's satisfied, it's correct for me. Maybe you have your criteria is satisfied for you, you agree it, right? That's just how you train the kind of a reinforcement learning in a task without a ground truth or without a verifiable answer. So that's how you train the model, and especially boat training. And now, after this, how many of you know about boat training? I still know? Okay, so maybe it's too technical for you. Okay, stay with me the last piece, okay? A third pillar, how you evaluate model. You don't have benchmark for your task, you don't have benchmark how you evaluate model. And the same, using a model to help me to judge, to evaluate the answer from my model. I have a lot of different access of model. I can use different model to judge my model, right? And when you build for your domain, you will have a lot of different domain, right? For us, we have manufacturing, we have robotics, we have physical AI, we have driving, and we also have medical domain. And then all of this is some of the domain we can't make the mistake. For example, in medical, safety is so critical, right? You cannot just tell the patient to take the medicine that like the medicine for the headache, but is take a medicine for the stomach ache is like obviously is a dangerous, right? So it's some domain that you can afford to fail, right? You have to consider which task and which kind of like important for you, which criteria important for you. And you can't even look at the final score to judge whether this model is good or not. You have to look specifically for your task. If they don't produce the score in your domain, in their tech report, or the model you get it somewhere else, you have to verify on your task before you can judge whether this model is good or not, right? You have to judge based on your task. Don't just the final score. And okay, how we build the grading system using AI model. Okay, it's simple, 5 domain, 4 different methods, 50 criteria, 31 benchmark, and 4 model. This is what I built and to benchmark our model. We have 4 M. Each M is the M is stand for method. Method 1, method 2, method 3, method 4, right? What is this? Method 1, which is when you have a benchmark or the kind of your task, you have ground truth. It's very easy. Example, we take the exam with the multiple choice question. It's actually 1 out of 4 options, we have 1 correct, right? In this case, you easy just matching, okay. If the model produces the answer A, and then the reference is A, is the correct answer. Easy, right? Simple. The second is when the answer is open-ended. So in this case, you have to kind of like building several criteria. From criteria, like I mentioned, you can build 5 different criteria, or 10 different criteria, or 20 different criteria, up to you. As long as you define criteria to verify how the answer would be the correct answer. Basically, I can say, okay, this answer is produce some answer that related to my question, yes or no, right? Is it answer longer than 50 words or 100 words? But in your case, you prefer the answer 50 words. Then criteria, is that greater than 50 words? Yes or no, right? You can just basically create 100 or 10 different criteria. It's just binary question. And let the model itself look at your model response. The judge model, I take OpenAI as the judge model, right? And then look at my model and look at the reference or somewhere, and then my criteria on the left, and then I put input to the judge model, and then they can easily help me to check and verify. And the third one is like you, for some domain like I mentioned, you really not afford to fail. Safety is so important, right? Then you have to using multiple judge, because sometimes we get more opinion from more people, we can more confidence on the answer. So this idea is just basically the same, but you have more than 2 or 3 judge. If all 3 judge all agree on the criteria, this is a good answer. I have 3 judge all tell me Gemini 3 Pro and GPT-5 and Claude all tell me this is a good answer. Then I'm much more confident this is a good answer, right? Basically, you're using more judge to help you to judge the answer. And then the last one is more about like the part that we have more about like judging like reference free. In here is like we don't even have any reference. We just have question. And now we have to find a lot of criteria. And these criteria you can see like define like, okay, the completeness, either this answer is produce the final answer or complete the answer, or many like general criteria to help you to get some sense about how these answers are about, right? Because we don't have any reference, we don't have any kind of like criteria exactly for this question. Then you can just building some kind of general criteria and then let the model go through it and judge the response. Okay. So, and then again, how many of you now know how to evaluate the model? If you, okay, great. At least I have one, yeah. I have success, yeah. Okay, so for us, when we build domain specific, we have a lot of domain that we care, and then the task itself. From driving, you have like, you will pay attention perceptioning. You have manufacturing, you will care more about factory action recognition, and many, many tasks. I'm not listed here, but it's a lot of tasks in each domain itself, right? You have to carefully design these benchmarks to evaluate this model before you put in production. You cannot just risk by just directly ship the model and then deploy it. There's no chance for you to fail several times. Similarly for physical AI and general vision. And I want to show some example that we built for manufacturing. So in this is a server assembly. As Foxconn that famous for EMS, electronic manufacture service. So in this way, we built the vision language model that can look at the worker. They install the server. This is GB300 server. And when they install, they have different steps. And then how this worker install right or wrong, right? We have to train the model and let's see, okay, how well this model can see this worker working right in our task that we require. So we can't find this benchmark on the web or anyone else, so we have to define this benchmark. And order for robotics here is like when we have the multi-view input, and then when the robot need to make decision, how can we know it's making it wrong or right? So we have to build a lot of criteria. Whether I put it 8 view of camera, and then their next action is they can't grab something else, but my instruction is grabbing the A, but it's grabbing B, so it would be wrong, something like that. And yeah, that is some case I try to show here. And for us, we will soon release our one of the multi-model vision language model that built for physical AI, and we release soon on Hugging Face. And you guys can check our Foxconn Research Institute Hugging Face. I think we have one public, and then we soon release. But for us, we build the FoxBrain for autonomous driving. At Foxconn, we have the manufacturer EV, but we also try to build the driving assistant, autonomous driving, and so assistant on the car. And we built the model for smart city, and we built it for a lot of different tasks, from a custom service to AI agent for document complete or automation process in the document office. And this early morning, our director delivered a keynote about healthcare. I think we built a model for supporting the healthcare system. That's a wide range of application and tasks here, but I just define here one example. And we built the model for assist worker to assembly process. We have so many assembly production line. We can use this different model to guide the worker to assembly a certain product in the right stage. And also we use for checking the quality, whether it's a good or this product is exactly right. All right, I just share the entire story about how you build the data, train the model, evaluate model, and then deploy it in your some K application. Hope you take away some kind of how to build the data engine by yourself in your application, and also train the model, try to find a way to train the model efficient, and then building the benchmark by yourself if you don't have any benchmark existing in your task or your application. And that's it. I think I'm happy to take a question. I think if you're curious or anything, please feel free to ask. I try to answer. And even if you guys shy to ask, I stay here for a while. You can catch up me.
Thank you very much, Dr. Tran Rick ค่ะ